Swayam Prabha. Digital India. Educated India.
Lecture 25. Today our lecture will be more focused towards repair of composites. So, when you talk about repair of composites, our focus is more towards polymer matrix composites. So, there are several structures today which are made for load bearing usage. So, these structures over a period of time, because of some damage which is getting introduced or the small imperfections which were there in the while fabricating a composite gets progressed over a period of time. So, how do we repair these composites? And as I told earlier also, thermoset composite is more popular as compared to thermoplast, because it had a liquid as a starting material and the processing is easy and it gives good tailorability, or it gives good drapability property to the required shape. So, these thermoset polymers have a problem of non-biodegradability. So, whatever has got fabricated, the lifespan has to be slightly enhanced for a few more years before getting thrown off. So, people all across the world are working towards structural health monitoring of these composites. So, here in this lecture we will focus on, if at all there is a damage, to a large extent how do we try to remove those damage or try to cover up their damage such that we enhance the longevity of their usage. So, the content of this presentation is going to be damage in composites. What are the different types of damages? One, it can be on the surface. Two, it can be in between, that means to say in the core and then start growing towards, which is quite a common in sandwich structures. Then we will also have for a tool we have to do is damage assessment, because until and unless you detect a damage and assess the damage, you can't think of a remedial measure. Then the third one is going to be contaminants, then types of different repair, and the last one is suffering and steppings which are involved in this damage. So, when we talk about damage in composites, hidden damage issues including manufacturing defect, which I was trying to tell. For example, a low velocity impact with which normally would not cause much damage may cause a sandwich structure to disbond between the skin and the core due to the poor adhesion during the manufacturing. This disbond becomes more common. So, generally in order to explain little bit more, what are sandwich structures? Sandwich structures are structures wherein which you have a softer core. This is called as the core and this is called as the skin. It follows the analogy of your I-beam. So, here this skin can be made out of glass fiber, carbon fiber or Kevlar, and they are just stuck on top of the core. This core can be a honeycomb structure or it can be a ordinary foam which you put in between. So, generally what happens, there has to be a stitching which is to be happen between the skin and the core. So, if this stitching is not done proper, this leads to disbonding. So, when we talk about normal composites where we do not have this core, this disbonding happens between the, or debonding happens between the layers, between the lamellae. But here what happens, it will happen in the top as well as in the bottom it can happen, and here all you have to do is, if there is a small mismatch or if there is a small void between the skin and the core, this leads to disbonding. And if this for a sandwich structure, even a small disbonding leads to a major reduction in the structural properties. See, unexpected damage sources, for example, an aircraft vertical tail part may be designed to withstand hailstone impact, but not being able to resist damage from being dropped during the shipping or removal for inspection. So, unexpected damages are, for example, dropping of a spanner on top of a surface. So, this is an impact which happens on the surface of a composite. So, those damages are called as unexpected damage sources. So, you can have hidden damage and you can have unexpected damage. So, damage in composite, the best repair technique are heavily dependent on the details of the structure. By knowing the structure, knowing the load what it comes, knowing the functionality, then only we can start thinking of remedial measures. In other words, because the composite excels as at being tailored to meet the specific needs, there are few universal materials and methods that can be used to achieve successful results. However, there has to be a case by case approach for dealing in correcting the damage in a composite. So, this is a damaged composite and this is the rectified composite. You see here completely it is rectified. So, they have put a patch which is another composite of required orientation whatever it is, and then they have been colored, that means to say they have been given a coating on continuous coating, so that it looks to be the same as the original part. The damage in composite component is not always visible by naked eyes. So, it can be on the surface, the damage. If you take a composite, the damage can be on the surface, the damage can be on the core. These damage are called as surface damage, these damage are called as core damage or hidden damage, core or hidden damage. So, it is not possible to understand or find out the hidden damage through a naked eye. So, it is always required that we use some of the non-destructive techniques to find out this. For example, we have studied about the ultrasonics, we have studied about aquasto, optical ultrasonics, all those things. So, all these techniques are used to find out the location, the size of the damage. So, first we have to assess the damage and then only we should think of doing some remedial measures. The concept for composite repair of composites or the metallic structures is very simple. The bonded repair reduces stresses, the damaged region and keeps the crack from opening and therefore from growing. So, what we do is we try to create a vent. For example, if you have a composite and if there is a crack which is growing, so what we are trying to say is you try to make a hole so that this crack comes and hits at the hole and then distributes the energy such that the crack does not further propagate. The bonded repair reduces the stresses in the damaged region and keeps the crack from opening and therefore from growing. So, this is what is a crack opening happens and this crack is now bifurcated and the crack is not growing. So, some of the typical damages are, so because of the point of impact, generally what happens, the energy is getting dissipated in the composite like this. So, you will always have a damage which keeps growing towards the other side. So, here this point of impact can be a high impact or it can be a low impact. Low impact means small weights have been dropped, high impact means a heavy load is being dropped. And then you can also have this altitude. Which is very important, because we low impact, low altitude means the height is small, weight is small, so damage will be less. Low impact, high altitude, MGH. So, the potential energy will be MGH. So, H plays a very important role. It will create a huge damage. Same way with high impact, low amplitude, and then leaving this, there is one more parameter which is frequency. You can have low frequency or high frequency. So, this can be high impact, low / high altitude. Frequency again can be high or low. That means to say number of times the impact happens on a particular place. So, all these things plays a very important role. So, it can be impact, which depends on load, altitude, and it can depend on frequency. And all these things can be high as well as low. It can have multiple combinations to give this impact. So, this is on a monolithic laminate, this impact point of impact is there. So, this is how the damage keeps growing. The next one is dent in the sandwich structure. So, again this is a sandwich structure, top and bottom skin, and you have a core. So, this is a dent which happens. The next one is laminate splitting, maybe because of hygroscopic effect or the improper resin was there. So, low resin was there. So, these layers did not get stitched on properly. So, it is called as laminate splitting which is there. The next one is puncture damage in a sandwich structure, again because of the impact loads. It can be a bolt hole damage. While drilling a hole, there is a crack which happens and this crack keeps growing. Generally, when a hole is done, there is a possibility the cracks will go in the lateral direction. So, this is a bolt hole damage, and the other one is heat damage. This is basically because of the heat getting applied to a sandwich structure, the area, the polymer resin gets heated and it forms a damage. So, these are the different types of damage which are common in composites. So, what are the different basic repair processes? So, there are fundamental steps which are involved. So, the first step is to inspect and assess the damage. Next is remove the damaged material, whatever was there we gouge it out and remove it. Then treat the contaminated material. So, whatever was removed and then at the joining interface we try to do it. Then prepare a repair area. So, generally the repair area is we try to gouge some amount of good material also, so that we can try to have a uniform laying of it. Then complete the composite repair, inspect for the quality assurance, and then restore the surface finish. Restore the surface finishes giving a very smooth layer. So, these are the steps which are involved. So, first if you see, if you want to write it, it is inspect, and then we try to make strategy, or we try to prepare repair solution or mat or whatever it is, and then from there what do we do it? We try to repair the damage, and then after repairing the damage we try to check for quality assurance, and then we try to finish the composite whatever is to be repaired. So, these are the steps. Any composite which undergoes damage, these are the repair procedures. First inspect and find out where the damage is, come out with a strategy for repairing it, then try to repair the damage, then after repairing please check for the quality assurance, and then you go for finishing such that it can be put into good use. So, what are the different types of assessments? So, the damage of a composite is often hidden. So, it cannot be done by naked eye. So, what we do is we always go for a non-destructive testing method to do it, where a metal structure it can show up the dent and the ding after being damaged. In a composite structure may show no visible sign of damage and yet may have delaminated plies within it. So, what I am trying to say is, if you look at this structure, so here top and bottom it will be perfect. So, you will not see any defect, but in between in the core you will see lot of defects which are getting grown. So, that is what we are trying to explain here. The impact energy, which I told you there are three different categories which it can fall. So, the impact energy affects the visibility as well as the severity, the impact energy. So, how do you calculate the impact energy? Impact energy is it is nothing but the potential energy, mgh, right, and then frequency also you will try to add. So, as well as affects the visibility as well as the severity of the damage in the composite structure. High, medium energy impact, while severe are easy to detect. Low energy impacts can easily cause hidden damages, which the damage gets distributed. So, this is a typical high energy impact. So, high energy impact you can see these are the laminates. So, when the impact falls, the crack grows between the lamellae. So, and then it tries to debond, and then if the load is very heavy, it tries to break open the break the composite or a drill through the composites and then goes to the other end. So, this is the damage which is created, and these are nothing but the delaminates which are getting formed between the layers. So, here are the different orientation of the composite which is used. So, this is a high energy impact. High energy impact is, for example, a bullet fired as against a composite. So, this is a high energy impact. If you look at medium energy impact, so here what happens, there is a dent which is formed on the top, the energy has to be dissipated. So, the energy is dissipated as a cracks which are getting formed in between the layers. So, you can see that the base you will have a small breaking out coming, and then you will have in between cracks between the layers. So, it can be intra or it can be inter laminate cracks. So, these are the delaminations which are getting created. At a very low energy impact, there is no damage seen on the top, there is no damage seen on the bottom. It is only the crack which grows all inside, and it is very hard to find out, but it is a low energy impact. These are dangerous. Many a times these are the cracks which are not visible, and it keeps growing over a period of time. So, in composites all you need is, if you have initiated a crack, these cracks keeps growing very fast between the layers and within a layer. So, high impact you can see very clearly, and then there is a damage. Medium, again there is a small damage seen at the exit side. In low there is no damage seen. So, this is the dangerous impact, dangerous for the composite is concerned. So, this example is a bulletproof jacket as a bullet firing, and this is an example of a weight of maybe 2 kilos falling on top of a surface. This is a small spanner falling on a top of a composite surface with no damage, but creates with no visual damage, but has a damage within this material. So, what are the different contaminants? The contaminants damage area may always absorb moisture, because there are cracks, and these cracks are and polymer is hygroscopic in nature. So, it absorbs the water molecules, so which will prevent achieving a successful composite repair. So, what we do is, first we have to remove all those contaminations. The solid laminate contaminates with fuel, oil, etc. may be treated by wiping through with a solvent, using a reagent grade solvent for a final wiping. So, that what we do is, we somehow make sure this absorbed moistures are released out. So, this is very important. It is important to know what the composite is made of. Suppose whether it is made of thermoplastic, thermoset. In thermoplastic, what is it? What is the effect of hygroscopicity? What is the effect of a solvent reacting to it? All these knowledge is required. So, it is important to know what the solid is made of, what is the contaminant which is present there, and we have to check for a procedure to and then choose a solvent such that the contaminants are removed from the damaged area. It is easy for a laminate. Suppose if it is there for a sandwich composite. So, in a sandwich composite, if the core in a sandwich composite is contaminated, replacement of the affected material is the best answer. A core. Suppose if the core, if it is not possible, then we have to look for alternatives. So, what we do is, we do solvent cleaning, and maybe possible we will try to vaporize, or what we do is, we try to degrease that part and then remove that part. All the affected composite materials must be dried before repairing, so that all the solvent is removed. If you keep repairing in the presence of the solvents, then that is going to be a disaster over a period of time. Then performing a repair using a high temperature curing resin or a pre-peg, all the moisture must be removed to prevent steam from the forming and disbanding the repair. So, if you want to do it, now it has been very clearly said, for repairing you need to, it is better to choose a pre-peg. And when you use a pre-peg, it is good to remove the moisture and then start using it. So, the types of repair: cosmetic repair. Suppose if it is only a dent on the surface, so then what we do is we try to use a filler and then fill the place where the damage happened. So, a superficial or a non-structural filler is used to restore a surface to keep fluid out of penetrating or getting fluid getting retained in the small dent. This type of repair will not regain any strength. So, it has no strength, it is only a superficial. So, this can be thought of. Due to very high shrinkage, the composite repair may start to crack after a relative short period of time. That means to say, there is a difference in expansion or contraction with respect to the service conditions. So, there might be a crack which grows in this direction after a short period of time because of the dissimilar materials. So, this is cosmetic and there is a small dent on the surface. The next one is resin infusion. So, this type of repair can affect only in a limited instant where the delamination is restricted only to one ply. Then we always go for one ply is just on the surface. So, this is a composite. So, you have plies. So, this injection can happen only in this direction. So, this is a layer. So, these are the laminates and this is a ply, one ply. So, here the resin infusion injection or injection. However, not much strength is regained in this. It is again primarily filling up a gap which is there and it is very quick and it is very cheap. At best, this type of repair can hope to slow the spreading of the crack. So, this can be used for low impact where there is intra and interlaminate cracks. This resin can inject and then start doing it. So, this is how it is. A syringe is made. Okay. Through this syringe what we do is we try to push in the resin, so that this is a delaminated area and the vent holes around periphery drilled hole approximately 1/4 of an inch from the edge of the delamination. We try to make small holes and then through that we try to infuse resin through this and then we try to see the damage. So, this is the repair material, this is the delamination. So, this is the repair material. So, this is for a honeycomb structure and it can also be used for one ply damage, that means to say just below the surface. The next one is semi structural plug or a patch. So, this type of repair can regain some amount of strength. Mechanical fastening plugs, a core plug or a patch repair can especially affect where the thick solid laminates are used, since they take bolt load as well. Okay. So, here what we are trying to say is, here is the skin and here this is a honeycomb structure. So, here is a semi structural plug. What we do is we put a plug in one direction or we put a plug in the one direction and then we close it in both sides. So, this one is called a semi structural plug or a patch which is done. Here it tries to take load. Then structurally mechanical fastened doublers. So, these are the doublers. So, here what do we do is we try to have bolt patch repair. So, here what we do is we make small holes, okay, and then we try to put a patch or a steel plate or something. So, this will have several holes. So, this patch is just put taking away the damaged area. This is a cutaway. So, then this is given on the top, there is a plate on the top, then we fasten these two, so that we try to have a very good strength. So, this is called as bolted patch repair. So, here a doubler is a localized area of extra layer of reinforcement, usually to provide stiffness or strength for fastening. So, or any other abrupt load taking such a repair. So, here this is what which I discussed here. So, here this is often the only practical means of repairing such structures. However, such repair are not aerodynamically smooth and may cause signature problem in structures where low absorbability by radar is required. So, when we try to do any of those damage repair, we try to introduce foreign materials which might affect the aerodynamic as well as the other radar applications for signature whatever we got. Now, the signature gets disturbed, maybe this will try to change the radar response whatever you have. So, the last one is going to be structural bonded external doubler. So, here what we do is we try to bond external doubler are used to perform repair on the light loads on thin laminates we use. So, this is for thin laminates. So, it is especially common in wet layup material. There may be room temperature or high temperature cured depending upon the matrix of this resin. So, these repair can regain a significant portion of the original strength of the structure or even full, although with the significant stiffness and the weight penalty in some cases. So, this technique is very commonly used for thin laminate damage techniques. So, structural bonded external doublers are used. Then structural flush repair. So, this repair restores full structural properties by forming a joint between the prepared repair area and the repair patch. So, a damaged area is there. So, this is a damaged area. So, you prepare a patch here. So, there is an attachment between the patch and the original material. The repair patch is made by replacing each ply in a composite laminate that has been removed from the damaged area. So, this is what is a structural flush repair. So, the structural fly, what happens is, so this is what is a structure. So, we try to gouge out all the material from here, and then what we do is we try to replace it with a cut laminate exactly to that gouged area. So, the plies will be cut accordingly, even the orientations can be laid accordingly, and then you try to get it. So, these are the fibers, these are the original structure, and these are the adhesives which are put such that this fellow and this can stick to each other to form a structural flush repair. So, in this the strength is regained to a large extent. So, scarfing after completing the initial damage removal, the area around the repair must be ready. So, the corner of the repair hole must be rounded off and the hole itself should be tapered to provide the best load transfer when the repair patches is bonded to it. So, basically what scarfing means is, scarfing means that before the damage is completely removed, the preparing the area for such a way such that you try to get the best out of it. The scarfing on the taper sanding is usually achieved by compressed air powder with high speed grinder. So, we prepare the area in trimming it such that we can have a proper patching. So, here it can be ply determination or the scarf angle determination are two important parameters such that you get a proper scarfing. So, it is important to know the number of plies in the composite laminate. The ply orientation are not needed for preparing a the damage area, but will be needed for cutting repair material and fabricate the repair patches. So, here as I told you, first you have to cut the ply is important, and then you have to make a taper. So, this too is done by the scarfing. So, here is it. So, here you are damaged. So, here we prepare the double sided, and then we put we find out the scarfing distance, and then we try to put the layer. So, this is the scarfing angles. So, it can be single sided, it can be double sided, whichever you want you try to take, and then you try to prepare. So, if you see that the scarfing angle, the distance is nothing but from here to here, we prepared such that you can have a proper repair patch. So, scarfing versus stepping. So, stepping is an alternative method. So, here in stepping what we do is we make it into steps, and in scarfing we make it as a tapered angle. So, that is the difference. So, if you see the stepping is an alternative method of removing material in preparing for applying a repair patch. In stepping, the overall angle is achieved by removing a precise area of the material ply of the composite laminate. Both methods, scarfing and stepping, works very good. So, here is what is stepping. So, here this is what is called as scarfing. So, you have a smooth transit, here it is not a smooth transit. So, with this we have studied the different ways of doing repair of composites. So, in repair of composites, these are the steps which are involved, which I would like to repeat. So, inspecting the assessed damage, then remove the damaged material, then treat the contaminants if at all there is any, then we try to prepare the repair area, then complete the composite, assess the quality whatever you have done, and finally, we try to restore the finish such that you get the best out of it. Thank you very much.